Okay, I suggest that we slowly start. First of all, a couple of housekeeping rules for this 1 hour workshop. You can post your questions using the Slido tool. You can see it in your Teams application. You can do it during the course of the workshop while the speakers are speaking, but they will be processed later, closer to the end of the workshop in the Q&A sessions. Also note that the slides will be uploaded at ACER website since tomorrow, and also the workshop has been recorded. A short introduction on the topic. As you know, the Clean Energy Package provides different definitions of congestions. In the electricity regulation in Article 2, we have the definition of the congestion and also structural congestion. In CACEM regulation, we have definition of physical congestion and again, the definition of structural congestions. However, what is the point of this study and this project? That the links among the definitions are not fully clear and can be subject to interpretations. In particular, the link between congestion and physical congestion does not specify any relevance threshold. Besides that, the essential definition of structural congestion, although it's quite similar in the electricity regulation and in the CACEM, lacks clear definition of predictability, stability, and frequency, and clarity whether it applies separately to congestion or physical congestion. These were the main reasons for ACER to for ACER to engage the consultant, which are our colleagues from Engie Impact and Janson, to conduct this study, which would propose clearer, simpler definitions of congestion in electricity networks. You will see we will discuss physical congestions, areal congestions, and structural congestions mainly. From ACER's point of view, of course, this is one out of possible views on the topic, but we intend to use the outcomes of this study and feedback from this workshop also in our further work possibly in the CACEM 2.0 revisions and in related methodologies. Regarding the agenda for today, after my short introductory remarks, we will have Marina with review of existing definitions and proposition of improved definition. Then after that, Guy will provide legal and regulatory changes. And finally, Pierre will provide a few information on stakeholder survey results and general conclusions and perspectives. Then we will have Q&A session, which will be moderated by Matthew, and on basis of your Slido inputs. And finally, Martin would provide closing remarks and wrap up the meeting. So if this plan is okay with you, I would now hand over to Marina for the first part of proposition of improved definitions.
Thanks, Zoran, for the introduction. Good afternoon, everybody. So I will start, as Zoran mentioned, with the review of the existing definition, and then I will move on to the proposed amendments. I will start for a small introduction, just to quickly mention that this project was performed by the consortium composed by Engie Impact and Janson, and I would like to mention that our group of consultants as Engie Impact will perform the next assignments as under the name of Tractable, which is still an engineering company under the umbrella of the Engie Group with offices all around the world. But then we will go through let's say this change of name under which we will perform the next studies. And I would also like to underline that this project was performed by us as independent consultants, so it does not represent the view of the whole Engie Group on the topic, but is a specific study performed by Engie Impact. So I will, even if Zoran already performed a brief introduction, I would also like to mention that as we mentioned already, there are different congestion definition in the CACM and the electricity regulation, and there are some elements of unclarities, ambiguity, especially in terms of how these types of congestion should be identified and studied, and how they interrelate, what are the dependencies in between these different types of congestion. And this is really important because this definition and these elements really influence some important processes, especially the bidding zone review, which is specifically affected by the definition of structural congestion that, as Zoran mentioned already, has a list of characteristics which are not really clearly specified. There are no threshold, no explicit interrelation with the other types of congestion. So this makes it a bit difficult to actually be able to distinguish between structural and non-structural congestion. That's why we performed this study. So there are three main objectives. So the first one is to identify these different type of congestion, how they relate with each other, and then use this first piece of information in order to go a step further and then see how we can distinguish between structural and non-structural congestions. And finally, the next step, which is the one performed by Janson, is to really see how these proposed amendments to the definition can practically be implemented into a regulatory framework. So I will start by the review of the existing definitions. So I will go through all of them by seeing what's existing and try to identify the drawbacks and the interpretation that we provided in our study on these current definitions. So if we start from physical congestion, we have this definition in the CACM regulation, which says physical congestion means any network situation where forecasted or realized power flow violate the thermal limits of the elements of the grid and voltage stability or the angle stability limits of the power system. So in this definition, the main point of attention for us was the word violate, because if a limit is violated, in our interpretation, it means that this limit is not a constraint included at the level of capacity allocation. So we can only assign, let's say, the name of physical congestion to elements which are just studied, let's say, after this step, which are not included as constraint in the capacity allocation. So that's why we consider that there is a reference to this, let's say, market step somehow, but then it also creates confusion with the coexistence of the terms forecasted or realized power flow, because the element of forecasting kind of implicitly points at a specific market step without then specifying which market step we are referring to. So it kind of leaves the door open to ambiguities in terms of how this physical congestion should be identified. So we find this definition a bit unclear in terms of when the study and the analysis and the identification of physical congestions should happen. Then if we look at the market congestion definition, we have it also in the CACM regulation, and it says market congestion means a situation in which the economic surplus for single day ahead or intraday coupling has been limited by cross-zonal capacity or allocation constraints. So here we have, let's say, a different use of words. So we talk about limit of the surplus. So this means that we consider network elements which are included as constraints at the level of market coupling, because we don't talk about violation of limits, but just limitation of, let's say, further increase. So this means that these congestions are evaluated by means of constraints, by active constraints within the market coupling algorithm. So we have, let's say, a different perspective with respect to physical congestion, even though it is not clear how this definition relates to the definition of physical congestion. So we also identify this as a drawback of these two definitions, as there is no reference of the other one in any of the two. Then we have an additional congestion definition in the electricity regulation, which kind of has a more general kind of feeling, let's say, because it says congestion means a situation in which all requests from market participants to trade between network areas cannot be accommodated because they would significantly affect the physical flows on network elements which cannot accommodate those flows. So we identify different drawbacks in this definition because we find it very broad, and thus this makes it a bit ambiguous, because in this case we again don't have any reference about the step when these congestions should be identified. So there's no it is not distinguished whether this congestion should be managed at the level of the market coupling algorithm, as it is kind of explicited for market congestion, or if managed ex post through redispatch, which could be also the case for physical congestion, as we speak about both forecasted and realized power flow. So I have the feeling that the umbrella under which this congestion definition operates could include both physical and market congestion, because in both cases, in our interpretation of this definition, in both cases we have limitation, the inability to accommodate additional flows and all the trades from market participants because of physical limitation on network elements. So this general definition in our interpretation could be applied to both physical and market congestion. So this makes this definition quite general, and this is one possible interpretation of this definition, not the only one, which makes evident that it needs clarification in order to be applied more in a straightforward way and make it clear to what it is referred to. So there is no clear relationship with physical and market congestion, and also it has a reference to network areas which are not defined anywhere else in the regulation. So it also a small point of further point of ambiguity for this definition. Finally, for structural congestion, we find, as Zoran mentioned, the definition in both the CACEM and electricity regulation. I will read out the one present in the electricity regulation, which says structural congestion means congestion in the transmission system that is capable of being unambiguously defined, is predictable, is geographically stable over time, and frequently reoccurs under normal electricity system condition. So the key drawback of this definition is, again, that there is no clear reference to when this congestion should be identified, in which step of the market or afterwards, and also what's the relation with the other types of congestion: physical congestion, market congestion, and congestion as defined in the electricity regulation. And we also have a list of several characteristics for which there is no further explanation. There is no threshold defined, and this is especially true for this frequently reoccurs, which would really call somehow for a threshold in order to then be able to say, okay, this is structural, this is not structural, but this is not the case for this definition, which is not also further explained anywhere else. So because it could be that some elements are missing in the exact definition, but then they should be clarified in the rest of the regulatory framework, but this is not the case for this definition. So we feel that, again, there are some ambiguities and some room for improvement in terms of clarity of the definition. So this slide summarizes our interpretation of the current definition, which is one of the possible interpretation, as I underlined already. So this is, again, a concept which points at the fact that it needs more clarity. So in our interpretation of the definition, we could say that after capacity calculation, we could already pre-identify physical congestion, and then after capacity allocation, we could actually acknowledge market congestion, which would arise after solving the allocation constraints and seeing which are the active constraints in the model, and those would be the market congestion. And then afterwards, we could run a power flow, assess the flows in the rest of the elements of the network in order to identify the forecasted physical congestions. Finally, after this would point at the network elements which would have to go through remedial actions. And after remedial action, normally the forecasted physical congestion would have to be solved, while it could still happen that physical congestion might appear in real time. So that would refer to the realized power flow, which are mentioned in the definition. And given that the general definition of congestion in the electricity regulation, we interpret it as quite general and broad, we would indicate that those general congestion could arise throughout all these steps, because they would include all the other types of congestion which are defined in the other definitions. So this is the interpretation that we gave of the current definition, and we clearly see that there are ambiguities to be solved. So the next step for us is to try to propose some improved definitions, some amendments that, in our opinion, could lead to more clarity in this definition. So we try to meet certain requirements, so to limit the room for interpretation, so to clarify the definition, or at least foresee that if something is still left somehow open in the definition, then it should be better clarified somewhere else, in some other articles, in some other parts of the regulatory text, in order to make it clear, to identify, study, and assess the presence of the different types of congestions. Then the application of this definition should be straightforward, and the relationship between the different types of definitions should also be clear and explicitly defined in the definitions. So I will start from the physical congestion, for which, also based on the analysis of how congestions are defined in other countries, in other parts of the world, we identify two main approaches to define physical congestion. So on one side, the focus could be on the impact of accommodating all requests from market participants. And this would mean that they would have to be detected through unconstrained market run, in order to really look at all the, let's say, the wished trades of the market participant, and be able to identify all the network limitations that do not allow for this ideal trade. The second approach is instead focuses on the impact on an incremental impact on the economic surplus, which means that we're not looking at all the network limitation in an ideal market, but we're actually taking the constraints of the network elements into account, and we are only identifying as congestions the ones which are actually binding in the real case, let's say. And this approach would require a different way to identify this congestion, which could either be a security constrained OPF or zonal market plus redispatch. I will clarify this approach by means of a really small example. So if we look at this system here, at this two-node system, we could see that the price of energy in node 1 is much lower than the price in node 2. So in an ideal market, the most convenient solution would be to supply these 2000 megawatt of load by providing it with the generator at node 1. So to transfer 2000 megawatt from node 1 to node 2. But we can see that this would exceed the technical limits both of the transformer and the line. So if we adopt the first approach, so we look at the ideal market, what would be the exchanges in this unconstrained market, then we would identify as physical congestion both the transformer and the line. While if we look at the incremental impact, so we actually look at the solution of the market, which in this case would mean to transfer only 1400 mega in order to respect the constraints of the different network elements, this would mean that the only binding constraint is the transformer, because the line would work well below its technical limit, and it wouldn't be true then that it wouldn't be able to accommodate additional flows, because it's far above its technical limit, far above the actual transfer of power through that line. So you see that the two approaches actually imply a difference in the elements which can be identified as physical congestion. And they are both relevant for different reasons, but we also see different applications, let's say, for the two different approaches. So we feel that the first approach is more interesting for grid planning, because it allows to actually see how to fulfill, let's say, the dynamics of an ideal market and what are the network reinforcement needed in order to reach that ideal situation. So this is more a long-term investment and interest of the stakeholders in seeing how the network should change, while the second approach is more interesting for what concerns the revision of the market structure, the assessment on whether the market structure is efficient and allows for the best possible solution, given the limitation of the current network. So given that the application of the definition of congestion, and especially structural congestion, is pivotal in processes like the bidding zone review, we feel that the second approach is more suitable for an improved definition, because this would specifically look at the process of bidding zone review or the implication of market structure, and would be more suitable to efficiently perform in this direction. That's why we decided to reformulate and amend the definition of physical congestion, having this approach in mind. So only looking at the binding constraints, because these are the ones which are immediately interesting in the analysis of the market structure. So the proposed definition for physical congestion is the following. So for each definition that I will propose, you will see the current definition with the strike through wherever the text has been eliminated from the old definition, and then underline text whenever there is a new addition, in such a way that you can clearly appreciate what's been changed with respect to the current definition. So basically, the way we propose to reformulate the physical congestion is physical congestion means a network situation on one or several network elements simultaneously, where a further increase of power flows on these network elements would lead to or increase the violation of operational security limits. So there has been multiple, let's say, action on these definitions. So on one side, we tried to make it clear also on simple elements. So for example, we specified somehow the meaning of network situation, which was also quite general and not really specific. So we tried to make it more somehow physical by specifying that it acts on one or several network elements simultaneously. And we also try to use the definition which are already available in the regulatory framework in order to simplify the way this definition looks. So we use the definition of operational security limits, which is already in the regulation, in order to simplify the current definition, which has thermal limits, voltage stability, and angle stability limits. So we just try to make it smoother from that point of view. And then the key focus is that we added the reference to further increase of power flows on network elements. So this makes explicit this approach that I mentioned, the second approach that I mentioned, that we only look at binding constraints. So we're not looking at accommodating all requests from market participants, but we're looking at which are the actual binding constraints once the, let's say, the different steps of the markets are solved. And we also removed the reference to forecast or realized power flow, which we felt were making the definition quite ambiguous in terms of when to identify this physical congestion. And by removing this, in our opinion, the definition is more clear, and that it could be actually identified in all the steps of the market at the stage of redispatch, and also in real time in case of forecast errors and other issues that could lead to physical congestion in real time. So by removing this reference, in our opinion, the definition is more clear about the fact that physical congestion could happen throughout all the steps of the market and afterwards. So this is how we propose to amend the definition of physical congestion. The amendment is quite reduced for what concerns the market congestion, because the only proposition that we made is to extend the reference to economic surplus not only to single day ahead and intraday coupling, but also beyond. So only mentioning during capacity allocation and removing single day ahead or intraday coupling. So the new proposed definition would say market congestion means a situation in which the economic surplus during capacity allocation has been limited by cross-zonal capacity or allocation constraints. Then let's say this is the key part of the amendment that we propose, because here we propose to use the existing definition in the electricity regulation of general congestion to try to make it about let's say a new specific definition that would allow to really look at the trades leading to congestion on physical network elements, because we have definition of physical congestion and market congestion that actually point at specific network elements, but we don't have currently any definition that kind of looks at the trades which cause this physical and market congestion, because then there could be loop flows. So it's not given necessarily that a congestion in a certain point is caused by trades in that specific area. So the areal congestion definition tries to tackle this problem and try to go at the root origin of the issue and see what are the trades which are contributing to this physical congestion, which are making my network not being able to allow all the trades that ideally would be needed in order to have an efficient market. So this new definition would say areal congestion means a situation in which all requests from market participants to trade between two network areas cannot be accommodated simultaneously because they would significantly contribute to a physical congestion on at least one network element. So in this definition, we introduced the word areal in order to specify the type of congestion and make it different categories instead of something quite broad, which was not clear whether it included the other categories or not. We propose also to specify the meaning of network area as a group of nodes, because this is currently missing in the regulation. But then the key point is that we modified the way this congestion is defined and identified, because we move from affect the physical flows to contribute to a physical congestion, in order to really clarify what's the role, what's the meaning of this type of congestion, because affect the physical flow is really general. The word affect does not really give a direction, does not really give information what's the impact on those physical flows, and also it's not clear which physical flows are we talking about. While now this is made transparent by mentioning explicitly physical congestions and saying they significantly contribute to a physical congestion. So it is clear that then an areal congestion can be called that way when there is a worsening, let's say, of the physical congestion. So we build a relationship between these two types of congestion. We establish, let's say, a direction, because this areal congestion is such if there is a significant contribution to a physical congestion. So of course, if it makes it worse, if it contributes to build, let's say, this physical congestion. And we left from the previous definition the word significantly, because then again, it is relevant to identify and assess these types of congestion if there are actual impacts on the network, because we can consider that a trade and exchange in the extreme western part of Europe still has an impact on the specific flow of a line in the extreme east, but then it's most probably negligible. So it's important to assess, is it worth to consider the contribution of that trade on that specific line, which is maybe physically congested, but we cannot really say that a major contribution is that trade on the other side of Europe. So it is important to keep this concept of significance, which is left let's say, general in this proposition of definition, but then in the next slide, I will further clarify exactly this step of the definition. So here, what we see is a proposition of the methodology to actually identify these areal congestions. So by means of an explicit set of steps, which translate that part of the definition significantly contribute to a physical congestion. So, and this is just a proposition, then Janson will also mention this part about the methodology to identify areal congestion, and will also propose an alternative. So what we propose at this stage is to identify the two network areas, and then once the exchanges between these areas are assessed and the direction of flows are identified, then we can assess whether these flows contribute to physical congestion. So we check which are the physically congested elements, and we see if these trades go in the same direction. So they actually make the situation worse, they actually play a role in this physical congestion, or if they go in the opposite direction, then they actually do the opposite. They tend to relieve the congestion. So then it's not interesting to go further. While if they actually contribute to at least one physical congestion, then it becomes interesting to check if this contribution is significant or not. So we had, in order to assess this, we used the area-to-area PTDF in order to check the impact on that specific line of the exchanges between the two selected areas. And the significance threshold that we propose is the 5%, which is also mentioned in the Article 5 of the core capacity calculation methodology, because that article talks about cross-zonal exchanges and when they can be considered to significantly impact the flow on a network element. So as the domain is the same, we propose to keep consistency between those two significance thresholds. This threshold is also under discussion and could be changed, but this is, let's say, a preliminary proposition for this significant threshold. So this methodology could be a way in order to define whether we have areal congestion, which is trade between two areas which significantly contribute to at least one physical congestion. Finally, there is the definition for structural congestion, and the first question in this case is, for which type of congestion is it relevant to assess whether it is structural or not? In our opinion, it is not relevant for physical congestion because they really look at physical elements and they don't give information about the market structure. It is not relevant for market congestion because, again, it looks at specific network elements which are on the border between bidding zones, but they don't really look at the trades which contribute to this congestion. So then we consider that it is relevant to actually look at the structurality of areal congestion, because these are the exchanges that lead to trades that contribute to such congestion, and they could also present recurring patterns, and the same trades could, based on the different time step, could also affect different network elements and contribute to different physical congestion, but could also be traced to the same trades between areas. So we feel that the areal congestion are the ones for which it is interesting to assess whether they are structural or not, because they kind of go at the source of the issue and how the market is influenced and can be changed in order to improve this aspect. That's why basically the only amendment that we propose for structural congestion is to establish a relationship between structural and areal congestion. So the definition would basically remain the same. We just add the word areal congestion in order to establish this relationship, and then specifying areal congestion also allows to somehow clarify part of these characteristics which are listed in the definition. Because if we look at areal congestion, it means that we identify two areas already and we're studying those two areas. So this means that this can be unambiguously defined. It is geographically stable over time, and we can also say that it's predictable because we can always model and forecast this situation. The only elements which is still critical and open is this frequently reoccurring under normal electricity system condition, and we felt it was really complex to define a threshold for this aspect. That's why the consortium of the project, together with ACER, issued a survey in order to hear expert opinion on the topic, and then Pierre later on will cover this topic. So just to conclude, this is an overview of our proposed view for the definition. So we can say that physical congestion is really the congestion on the physical network element, and if this physical congestion limit the possibility of different areas to freely trade in the market, then physical congestion could determine areal congestion if that areal congestion has a significant contribution to that specific physical congestion, and an areal congestion could also escalate to a market congestion in case this involves the lines at the border between building zones. And as I mentioned, the only types of congestion for which we feel it is important to evaluate structurality is areal congestion. So this pictures the overview of what we propose for the improved definition, and now I will leave the floor to Janson in order to go a step further.
Thank you, Marina. So all the changes you have referred was we have to insert it in the EU legislation. So what we propose is changing in two sets of laws. The first one will be the electricity regulation 2019-943 of January 2019 on the internal market for electricity, and the other proposed amendment in the CACAM regulation of 2015, July 2015, establishing a guideline on capacity allocation and congestion management. We will redefine or, as you say, or add to Article 2 of the electricity regulation, areal congestion, as you said, Marina, and physical congestion, and we will modify a structural congestion accordingly. In the CACAM, we will take the same vision and redefine in Article 2 of CACAM market congestion, physical congestion, structural congestion, and introduce, as said, areal congestion and define what is the network area. And finally, we will introduce a new article on the methodology to identify physical and areal congestion. So if we look at the current definition of electricity regulation, we have already spoken about the congestion and structural congestion. What we propose, as said Marina, is to introduce the areal congestion in this article and to address the exchange contributing to congestion between network areas and explicitly reference to physical congestion. And we reinterpret structural congestion to align with Article 14. Remember, Article 14 of the EU regulation states very clearly that bidding zone must not contain structural congestion. So we will take over this element to redraft, as you said, the new definition. So we propose to leave it congestion as it is. So all requests from the market participant to trade between network area cannot be accommodated because they would significantly affect the physical flows. That is, we'll leave it as it is. And then we basically refine physical congestion by adding and exiting some words. Exit, as you say, Marina, the realized violation. exit the violation of thermal limit or voltage stability, exit the forecast or realized power flows. As you said, and as we arrive to the conclusion, we will therefore refer to the physical congestion as a network situation on one or several grid elements simultaneously. And you have given a very good example where further increase of power flow on these network elements would lead, not violate, would lead or increase the violation of operational security limits. So this is the first point where we still refer to security limit, but in a different way. Then the basic of our work is really to put forward this areal congestion. We, as said, we keep the congestion definition, and we introduce in this definition areal congestion. So, and meaning a situation in which all requests to exchange electricity between two network areas cannot be accommodated simultaneously because they would, and you have said already the word, significantly contribute to physical congestion on at least one network element. So exit the physical flows. Then we have structural congestion. We logically add areal congestion. So structural congestion means areal congestion that is capable of being ambiguously defined, is predictable, geographically stable over the time, and frequently reoccurring under normal electricity system conditions. So we keep those words that you know are predictable, geographically stable over the time, and then we have to refine a little bit what is frequently, and Pierre will speak about what is frequent under normal condition, reoccurring under normal conditions. These are some of the three new definition or draft definition that could be inserted in the electricity regulation. Then the second proposed element would be in the CACER regulation. And our proposal is to redefine market congestion, as already said, and go beyond day-ahead or intraday market coupling, and emphasize its interdependence with areal congestion and cross-zonal capacity constraint. Then clarify physical congestion by focusing on its impact on overall economic well-being and operational security. Reinterpretation of the structural congestion, and always the goal is to align these congestion definition with Article 14 of the same regulation 2019, which states that bidding zone must not contain structural congestion. And therefore, we will associate in the proposed definition this concept of areal congestion. And then, of course, areal congestion, and we have to define what is an areal group of node. And of course, again, the threshold to identify those areal congestion. So practically, in these CACER regulation of 2015, we add this essential element of areal congestion. We're already same definition and in the electricity regulation, exactly the same, of course. We introduce the new definition of network area, meaning a group of nodes. Market congestion, we want to link it with areal congestion, where areal congestion, as said, can escalate to cross-zonal capacity constraint. It could result in market congestion. So, as we will propose to redefine market congestion as a situation in which the economic surplus, and again, exit single day or intraday, larger coupling, economic surplus during capacity allocation has been limited by cross-zonal capacity or allocation constraint. Then two other redefinition or definition, physical congestion means network situation, and then exit the forecast and exit the thermal element, as we have seen on one of several grid elements simultaneously, where further increase or power flows on this network element would lead to increase the violation of operational security limit. As Marina said, the violation criteria is not a good criteria, so we would prefer to redefine as situation that would lead or increase the security limit. And then finally, the structural congestion. We again focus on areal congestion, meaning a structural congestion, meaning an areal congestion that can be unambiguously defined, predictable, geographically stable over the time, and is frequently reoccurring under normal power system condition. So we, by doing that, clarify its location, because it was one of the problems of the former definition, and we associate it now with areal congestion. Then two words were raised significantly and also the methodology to significantly affect. So there are two options. Either we put in the CACAM a sort of new article, could be Article 34, and we try to put a certain step to identify areal congestion. And the identification of two network area between which areal congestion is being tested, identification of requested exchange between two areas, physical congestion, impact of requested exchange on physical congestion, significance. This is one way to put this methodology, but there is another way that could arrive exactly to the same result. Alternatively, instead of putting those details in the CACAM regulation, we can ask all TSO to develop and propose a methodology for clarification of this congestion definition. And the methodology will be developed by the TSO and address the data requirement aspect. So this is basically what we suggest to put as a change in the law, in the energy regulation, in the electricity regulation, sorry, and in the CACAM. So I'll leave the word to Pierre.
Thank you, Guy. So you saw previously that a big question to define structural congestion is the frequency of occurrence. So we put in the definition is frequently reoccurring, but you can be aware already that this might be a little bit vague as such. So we understand that we need to precise what it means is frequently reoccurring. For that, we invited in May, June experts to give their views on how it should be quantitatively defined, how structural congestion should be quantitatively defined. So in other words, what should be the threshold? So we can say that if an areal congestion happens X% of the time or more, it should be considered as a structural congestion. And if it is less, it's not a structural congestion. The question is, what is this threshold X? And so following that survey, we had 31 responses originating, and this is important to note, not only from individual experts, but also from institutional stakeholders. And so we had not only answers on the numerical value on the threshold itself, but stakeholders took the occasion also to comment on the concepts of congestion that we just discussed and the associated definitions. So we considered, obviously, the comments to shape the proposed definitions. However, if you look in the report, we didn't formulate a formal answer to each comment, but I want to emphasize that between June and September, the first release of the report, these comments were considered, discussed internally, and the report was amended accordingly. We had over these 31 responses, 11 responses with a suggestion for a value for the threshold. We perform also an internal assessment based on past data of what could be a typical or relevant threshold. So what we recommend is to have a threshold between 5 and 10%. So in other words, if a congestion happens between at least 5 to 10% of the time of the market time units, it should be structural. Obviously, it's a first assessment. So our recommendation for us is that this value should be refined based on analysis for the European power system. Should we have more 5 or more 10, it could impact how many structural congestion we identify, and so the delineation in bidding zones. I will move now to the conclusions of this study and some perspectives. So I would like first to emphasize the contribution of this study. So what we try to do through the reshaping of definition and the discussion afterwards that we have in the report is to propose a consistent approach to identify structural congestions. And in particular, and we can come back to that in the Q&A session, the fact that structural congestion should reflect areal congestions and not necessarily directly, at least, physical congestion, even if I want to emphasize that to identify areal congestion, you need to identify physical congestion. But what is important for me is to state that bidding zone border should not necessarily be on physical congestion. So if you identify an element that is physically congested, the border of a bidding zone should not be necessarily be there. You need to study the areal congestion, so the interaction between the various nodes and this congestion. We propose to adapt consequently congestion definition in the relevant EU regulations, and we demonstrated also in the report, not today due to the limited amount of time, the applicability of the approach on a test system. So to conclude on our side, we would like also to emphasize that what we propose in the report is not the only possible approach to identify structural congestion. So we discussed a lot internally, and we acknowledge that we can have some variance on methodological points. I would like also to emphasize that at this point, because it was a limited study and we did not have the budget basically to have a major involvement of stakeholders, it should be seen more as an academic study, but nevertheless an important starting point for an agreement on the methodology at the European level. So I believe it's a good foundation, even if some open question remains, and especially for the ex post assessment of structural congestion. So we discussed a lot in the ex ante. So if you want to have a forward assessment in the future, what should be the structural congestion, the methodology there, I believe, is more or less clear. However, for an ex post, so if you look backward based on market data, how to assess the structural congestion, it's a little bit more difficult, especially because you have various markets, successive markets. That concludes the part of Engie Impact and Janson. So I give back the floor to ACER. Mathieu, you are muted.
Indeed. You hear me now, right?
Yes.
Okay, good. Perfect. So, yes, indeed, during the presentation, we already received some questions and also, well, sort of voted up. So thank you for that. My proposal is indeed to start at the top. And I think either Pierre or Marina I think will be the most answering most of them, but I think that also makes sense. So maybe indeed this first question, the question by Benjamin Senet is, with these definitions, you can have a situation where you have structural congestions with the market never being limited. Could you comment?
So, in the philosophy of the study, for us, the existence of a structural congestion is somehow a bottleneck in the transmission grid, and the optimal operation of the transmission grid should not depend so much on the exact bidding zone delineation. So what I mean by that is that if an element limits the transfer between of power between two areas, it should be considered as a structural congestion. Ideally, bidding zone should reflect a structural congestion. So if you have a structural congestion, ideally, it should be translated into market congestion if the bidding zone are well delineated. However, we can imagine the case where we have a single bidding zone at the European level. And so in that case, we have obviously still structural congestion within the European power system. So some elements will remain bottlenecks. But at the level of the zonal market, and maybe then it's important that what we mean by market, the zonal market, we will have no constraint. It's a unique bidding zone. And so, yes, we can have structural congestion with the zonal market never being limited if the bidding zone delineation is not in line with structural congestion. Does it address the comment, Mathieu? The question?
I think so. Yes. Thank you. So next question is by Morten Pinstrup. Question is where will areal congestion be used in the regulation, and what's the meaning of significant? Significant seems also very ambiguous. Maybe Marina can take this one.
Yes, like let's say that I believe the following slide in the presentation kind of clarified this already. So it is true that this is left quite open in the definition, but in the requirements we mentioned, we also said that not everything has to be perfectly made explicit in the definition itself. It is also important to maybe further clarify in other articles in the regulatory framework. So this could be the case, for example, for this element of significance. And we made at this stage the proposition of the 5% for the area-to-area PTBF as a threshold in order to define whether the contribution to a physical congestion is significant or not. So if we can consider that as an areal congestion or not, because this would be consistent with the significance threshold, which is already used for cross-zonal exchanges. So we feel that this relationship could make sense to keep it consistent, given that the two elements are in the same domain. But of course, this is also an element which is like a proposition at this stage, doesn't necessarily need to go through in this way, but we felt that given that we have already this significant threshold available in the regulatory framework in the same domain, it would make sense to propose this as a reference for significant threshold for areal congestion as well.
Thank you, Maria. The next question also by Benjamin is about the clean energy package. Clean energy package gives the right to member states to build, split or pay, linking to investments, splitting the bidding zone, or indeed paying for redispatch. Pay means relying on virtual margins and remedial actions. Are the definitions not restricting the choice to opt for pay or for redispatch? I know, Pierre, you want to take this one, or?
Yeah, I prefer maybe not to elaborate too much, because I am not so much familiar with the right to pay, how it is formulated exactly.
I think the right to pay generally means that rather than splitting, you accept bidding zone redispatch as the solution to every congestion. Yeah.
So I understand that, but I don't have in mind the exact formulation in the regulation. So what I can say is that indeed the logic behind the definition that we propose, the states imply somehow that costly remedial actions such as redispatch should be minimized somehow, because we shouldn't have structural congestion within a bidding zone. So indeed, what I can say is that depending on the formulation for the right to pay through costly remedial action, that's something that should be probably investigated further, to which extent there is then a contradiction with other articles of the clean energy package. But
maybe then the next question here for Marina, which is indeed on the areas and and how they are defined, basically, that an area can vary from one node to many hundreds of nodes, and how we would select the areas.
I would say that at this stage, the way we develop the methodology, it would be at first like a qualitative assessment by looking at the trades, the possibility of different nodes to the availability of generation, the need for loads somewhere else, and to try to identify, let's say, for the borders of each area, the number of nodes to be included. At this stage is not structured, let's say, with specific step in the methodology. I would, let's say, start with a trial and error approach, but this could be further refined in later stage. But at this stage is really about qualitatively looking at where the congestion are happening, where we have the focus of most of the production load, and where we see that we have mostly importing and exporting areas, and trying to define then the boundaries of this area by means of trial and error, I would say.
Thank you. I think maybe the next one might be one for Guy. For the proposed CACM amendments, a vision to be part of the CACM 2 revision, or for a later process?
Well, I think, thank you, good question. I think that we have no time to lose. I mean, so if we can use the quicker instrument, it should be used, yeah, because it should be current. There is so I would go fast, yeah, if it's possible.
Very good, thank you. Then let me check. I see something popping up or being voted up. So this one is indeed the proposed frequency range. So it's on the stakeholder values. So issue for Pierre. The proposed frequency range / value seems to be based on less than 7 responses in the end. Why does the report put forth the value despite such high uncertainty?
Yes, what we can say, so indeed, we were maybe among the 31 responses, a little bit disappointed by the fact that only a limited number of responses gave a value. However, the 7 responses that we mentioned in the report were elaborated with rationales behind. So it's just not values that were put without a rationale. So we were also convinced by the rationale behind, and we had also our own assessment of meaningful value. And so this is why we chose to nevertheless give a recommendation, but to say, so it's a meaningful range for us, but with the caveat that we believe a further assessment is needed. But we believe that giving a first range can help in the further discussion.
Good, thank you. The next question I have is from Nicholas Krieger. It's asking, wouldn't the supposed definition on physical congestion mean that a network element with perfect usage, 100%, would be physically congested? I think this links to the choice in the beginning, right? I don't know, Pierre or Marina wants to take it.
Yeah, so the idea was to say, okay, if you have two nodes, only 2 nodes, with an exchange of power, and then the amount of power that you would like to transfer is over the capacity of the transmission element. In that case, okay, if you have a single bidding zone as the output of the market clearing, you will detect indeed an overload. However, if you divide that into 2 different bidding zones, the market will clear just at the limit of the capacity of the transmission element. So you will reach 100% of the capacity, but with a shadow cost for the transmission constraints of the transmission element not equal to 0. So the fact that you reach the limit because you enforce in the optimization that you cannot exceed the limit, but you would like to go beyond it. And this is indeed what we recommend to do, is then to consider that the element that it corresponds to a physical congestion. You have a transmission element limiting physically the exchange of power between the 2 nodes.
Thank you, Pierre. I think then, sorry, it's interesting. I try to ask questions, but then other ones are being voted up. So on the question on flight 37, and I think it's on the stakeholder survey. What were the other approach considered in the study to define the frequency in the structural congestion definition, and why the interview was selected? So it's more on the approach taken with the interviews or with the survey, I think is meant. Yeah.
Yes, we didn't perform in interviews really. So it was a written survey where we collected written feedback, and generally how to define a threshold. Most of the rationales came from the past to look currently when we have congestion in the transmission system, how much time does it happen? And so you have typically the NSOA report on the bidding zone, looking at the frequency of congestion with good order of magnitudes for the frequency that can be taken from there. But I must understand that I'm not sure to fully catch the question. You are still muted.
Yeah, I see. Good. So I think I've a question by Morten Pinstrup here on the The question whether nodes are defined somewhere, whether it's on transmission or distribution level or both.
The study was performing the transmission system in mind.
Yeah, indeed. So, and then the next question on the relation between area and bidding zone. I don't know, Marina or Pierre, could take that.
Yeah, I would say that as was mentioned already about structural congestion, I wouldn't say there's, let's say, a direct relation between areal congestion and bidding zone. What could happen is that, let's say, areal congestion, if structural, then could lead to a reassessment on whether the market structure is efficient, and then reevaluate the current bidding zone structure. So it has an impact on the following steps, let's say, coming afterwards. Or another relation that we can see is that, as mentioned before, the areal congestion, if contributes to physically congested elements on the border between bidding zones, there is an escalation, let's say, from areal to market congestion. So then we have an implication of that areal congestion on the border between bidding zones. But we don't have, let's say, a direct relationship in the definition between areal congestion of bidding zones. But of course, let's say areal congestion comes a step before and then can have impacts on bidding zones afterwards in the further assessments that come afterwards.
Thank you, Marina. I think I have a question. Yeah, I think I have a question. Or did we have that already? Is it correct that we could have no market congestion, but ending up with physical congestion when virtual capacities are considered an allocation? I think we answered that, right? Or
no, not yet. We
okay. We discussed it internally. Okay.
Yeah,
Pierre, maybe you go on this one.
Okay. So yes, indeed, very good comment. In the presentation, we limited the amount of details. But we explained that a little bit more in the report, that if we artificially increase the available transmission capacity, for instance, to meet the minimum capacity requirement of 70%, some transmission constraints might be violated following the market coupling algorithm. And so we can have indeed physical congestion after the market coupling, even if we don't have market congestion. So if a constraint that was artificially relaxed somehow is not saturated at the level of the market, we don't have market congestion. But if it's a little bit below, we can have nevertheless an overload of the associated transmission elements.
Matthew, you're muted.
Sorry, so to do some moderation in the meantime on the question. So excuse me. Indeed, a question on maybe this one. I propose we take at the end after the Q&A session. We can say something about this on the stakeholder consultation. And any follow up on that. So then the question whether the notion of several network elements at physical congestion includes stability limit for further power exchanges over a certain profile. I don't know, Marina, you want to take that, or it's more for Pierre?
It can be me or Martin was yeah. Well, I can quickly say that indeed the notion of several network elements is to translate constraints that are not thermal constraints of a transmission element. So constraints related to voltage limits, it's then related to several network elements, or stability limits as well. So typically voltage stability and transient stability or small signal stability are linked to groups of elements.
Good, thank you. I think there's some questions on the term significantly. I think it's sort of the question, why do we need to add the word significantly? Market mechanisms limit trade already at 0.1 megawatt over the capacity limits. Do you intend to change this? I think this is linked to one of the definition.
It's probably the significantly contribute on physical,
exactly.
On the physical congestion. So the significantly contribute to physical congestion. It was detailed by Marina that it means that so if we have two areas and a network element, we need to ensure that the trade of power between these two areas actually significantly impact the flow of that element, because as the European power system is meshed, a trade between Spain and France will impact power flow in Poland typically, but almost in a negligible way. So mathematically, it will not be strictly equal to 0, but it will be very, very, very small. And so this is why we put a threshold on the PTDF, on the area-to-area PTDF, to say, okay, it must have a significant impact on the flow. But it's different from the threshold that the question disappeared, but the threshold mentioned for to bid on the market.
Good, thank you, indeed. I think a very high scoring question here is, what is the expected effect of the new definitions? Is it more likely that bidding zones have structural congestions and have to be reviewed/split? I assume it's hard to answer from your perspective with just a test model, but maybe you can give it a go.
Yeah, so again, our view here is to put elements on the table to make the definition of a structural congestion applicable somehow. So to propose an approach to say, okay, to be able to identify structural congestion. And it's true that when we read the regulation states that a bidding zone should not contain a structural congestion somehow. But that the effect, the actual effect, it's maybe more up to ACER to state a little bit what could be the following step. But I believe you will say that in the concluding comments.
Yeah. Indeed. Yes. Good. Then I'm looking at time. I think we can do a number of them. I see it took a bit of time for people to get started with their questions, because now they keep rolling in. Yeah. So the top. I'll just go top. So the question is, what our assumption or your assumption on the real actions in your definitions of physical congestion? Meaning, do you include or exclude the contribution of remedial actions?
So when we speak about remedial action, we need to distinguish costly and non-costly remedial action. So non-costly remedial action being typically redispatch, and non-costly, it could be topological action or action of phase shifting transformer, typically to manage overloads on elements, so to manage issues linked to the thermal capacity of elements. I believe to identify structural congestion, we need to have an optimized state of the transmission system. So we need to consider non-costly remedial actions that are available to avoid to over-identify structural congestion, because if you operate your system with a strange topology such that you have a lot of congestion, it's problematic. So you need to optimize the topology and other and the state of the grid in general to do that. So we include somehow non-costly remedial action in the base case to identify structural congestion.
Okay, I propose to have, I think, the last one or two questions. Yeah, I'm just looking at, I think, on the stakeholder survey. A question is sort of on the survey we only mentioned frequency and whether we can summarize the feedback received on the definition of structural congestion.
Yeah, we have a few comments. So the comments were, I would say, on the definition going in different directions. So I can mention a few comments that we received. The focus should not be on thermal overloads, and then we agree for that, and we discuss the fact that we go beyond thermal overloads. For distribution system, the concept of congestion is closer to the current concept of physical congestion. So in distribution system, we don't necessarily have the control on the generation and the consumption and the consumption. So you state that you have a congestion when you exceed the operational limits, and this is why. So we agreed with that, and this is why the definition tries to be a little bit general to include what could happen in distribution system. The optimal configuration of bidding zone does not reflect necessarily structural congestion. And then yes, but it's unclear what is the optimal configuration of bidding zone, and we don't want necessarily to open the debate of what is the optimal configuration of bidding zone. There was a comment that structural congestion should be addressed by grid reinforcement. And so there we do not necessarily agree because if the CBA if the cost-benefit analysis of the grid reinforcement is not positive, it's better to manage it with redispatch, basically, or at least with a non-optimal generation dispatch. Yeah, I believe that were the main comments that we noted. Yeah, and then for the frequency threshold, we had comments that the relevance of a threshold of the frequency is limited. It does not fully consider the impact in terms of redispatch cost. Then we tend to agree, but it seems difficult to derive simple and directly applicable methodology to consider as well the impact of congestion. And so threshold on the frequency is probably the simplest first step that could be improved afterwards. Another comment was to say it's not suitable to harmonize across all countries. Maybe for us, but then if we start saying, oh, each country could have its own threshold, there is a risk of keeping the status quo during a long time. Yeah, and indeed, the fact that detailed studies and consultation were requested. That's what I can say shortly, without going into every single comment.
So thank you, Pierre. I think I would suggest we close and we move to the wrap up by Martin. For this, I will. So there were some questions indeed being asked on next steps and process. So I would indeed put those questions also to Martin, well, introducing the wrap up. I don't know, Martin, are you? Yeah, you're there.
Yeah,
good. I also see you. So maybe to let me see what's the logical order. Yeah, let's start with first with the expected effect of the new definitions. So this question indeed whether it's more likely that bidding zones have structural congestion and have to be reviewed / split with these new definitions.
So this is really hard to judge because even today we don't know what's the likelihood. I mean, today we don't know what's the effect of the definitions on bidding zones. So because the definitions are not clear, the thresholds are not defined, neither the significance thresholds nor frequently occurring threshold. So we actually don't know what's the effect of today's definition on the bidding zones. That's why we don't have reference, how would future definitions be, whether they will be worse or better, because the reference doesn't exist. So with that definitions, we would only start making a reference by defining certain thresholds. And only then, if you change the thresholds, if you change certain element, you know what's the effect. But at the moment, we really don't know what the effect would be.
And then the second question is related to the CACM proposals and whether we understand that the report, that in chapter 5.2 of the report we propose to replace Article 34 of CACM, and how that would affect Article 32.
So, in my understanding, the way the consultant proposes, we would not replace, but we would actually add a new article, like Article 34A, which would specify certain elements which cannot be defined in the definition. We would specify certain elements in the article. For example, the process to define a threshold, the process to define a frequently occurring, or the process to define the areal congestion. So some elements would have to be defined in detail in the CACM and possibly in the methodology pursuant to CACM. So this would not be replacing, but adding additional article.
Good, thank you first, Martin. And then the last question, and then I think you can directly go into the wrap up. Is indeed the question whether ACER intends to organize a genuine stakeholder involvement on the topic, as 160 characters in Slido is not enough to solve such a complex topic.
Yeah. So for sure, what we had in mind is to organize a workshop with TSOs, because TSOs are highly interested in this topic. That was in our intention, where we, because today what you heard is consultant view and their opinion. We also have made some nuances here or there. We need to analyze them as well. But we may have different views that consult on some elements. So we would organize a workshop with TSOs on this level. But if there is a need from other stakeholders organizations, we could also organize meetings with them. In this case, we just invite you to contact us. You want to have a meeting on this topic to further discuss, more interactive. We could also organize a meeting with stakeholders.
And then, maybe any closing words from your side, Martin?
Yeah, so as I said before, I first would like to thank the consultant. This is a big study. It's an important study. It's not an easy topic. So the congestions and structural congestions are sort of like a taboo topics in the policy, in the energy policy world. We try to open this taboo and this Pandora's box by some technical quantitative assessment, and this study was aiming to do that. So it wasn't an easy project. So I congratulate the consultant to be able to deliver something meaningful. Having said that, the aim of the study is to raise questions, is to expose that there is a problem. The problem is that we don't know what these definitions mean. When we talk about congestions, we always have different things in mind. So it's hard to communicate with each other if we don't have the same things in mind. For example, the way when we talk about congestion, some consider this as physical congestion and some consider this as like congestion between two zones. And those two concepts are completely different. So we really need to understand when we talk about definitions what they actually mean. So this study is exposing the problem and raising a good question. If we try to clarify, what would be the best way to clarify? And on top, the consultant did propose a couple of solutions. Some of them are more elaborate, some of them need further assessment. But it's aiming to inspire the debate among experts, among policymakers. It's only the beginning. It's not the end of the story. But finally, after some discussion, after some analysis and further work, we hope to be able at some point to put some order into the discussions and to legal assessment. That's why we invite stakeholders, TSOs, to further work on this, to chew on these questions, maybe to come up with their own ideas and solutions. And then, after the soup is cooked and boiled, and then we can maybe come together and conclude commonly what's the best way to proceed. The worst thing is that we keep having this unclarity forever, and then this doesn't help anyone in our view. So with that having been said in mind, please expect, at least from TSOs, our invitation to the workshop. For stakeholders, if you want bilateral meetings, multilateral meetings with us, please contact us, and we're happy to accommodate. Yeah, and with that, I would like to conclude the workshop. So thanks a lot for all stakeholders, those who stayed at the end. And yeah, and please expect more discussions and more work on this in the following months and years. Thank you very much.
Thank you.
Thank you. Thank you very much.